Hello guys, welcome back to my channel Memo African Motives. In this platform we shall be working with the question paper on moments. So this is the question that we are having, which is extracted from one of the question papers for engineering science N3. So we are given question 2, which is carrying actually 12 marks. As you can see, we have 12 marks in this case. So we shall try by all means to explain so that we can understand how to answer typical questions like this. So not to miss these classes, make sure that you subscribe to my channel Memo African Motives, so that anytime you'll be part of the family to work with question papers and revisions for engineering science N3 and other subjects. Okay, so quickly rushing through the question, we are given to state two conditions for a beam to be in equilibrium. Okay, so we need two conditions. So it's actually the issue of what the sum of forces. We know that for upward forces they're going to be equal to the downward forces, the sum, and also the sum of the moments. So I think this in an easier way we can have this description here. Let me just try to adjust. Okay, so we have the 2.1 in this case. For a beam to be in equilibrium, the following conditions should be considered. Okay, so which conditions are we talking about? The sum of the upward forces is equal to the sum of the downward forces. Okay, so this is what we are actually referring to in terms of the summation. Sum of the upward forces is equal to sum of the downward forces. Okay, then we move on to the sum of the anti-clockwise moments is equal to the sum of the clockwise moments. Okay, so this is in short, the sum of the anti-clockwise moments will be equal to the sum of the clockwise moments. So it can be anti-clockwise and clockwise, or it can be clockwise equal to anti-clockwise, but the idea there is the sum. Okay, so these are the two possible conditions that you can actually refer to when you are referring to a moment that is actually in equilibrium for a beam. Okay, then on 2.2 in fig 1, a light beam ABCD of uniform cross section is loaded as shown. Okay, so this is a light beam that you're given, which is loaded as below. Okay, so let's see what you're having here. The first part is fine, but here there's something that is not okay. If we are to cross check, there is 10 kilonewton, but it's between the distance of 4 meters here. So which means this is supposed to be a distributed load that you're supposed to separate into two. Guys, you must check here, these are properly placed forces. This one is properly placed, this one is properly placed. But if you are to cross check, this one is pointing to this part here, which means it's a distributed load. So you're going to divide this into two. So like I always say, that it is best for you to have a new presentation now using the information that you are going to obtain from this part of the distributed. Okay, so which means this one, the 5 kilonewton, is going to remain as it is, which is at A. We have the 5 kilonewton here, which corresponds with the point A. Okay, then 1 meter to point B. Okay, so we have 1 meter to point B, which is actually a support. So this one is supposed to be represented with an arrow. Okay, now this is the part that I want to talk about here. So whenever you're given a distributed, you're going to multiply this distance, because this is actually 4 kilonewton over 4 meters. So it's actually to be like 10 kilonewton per meter, like this. So you're going to multiply 10 by 4 because it's covered for 4 meters. Okay, so if you multiply, you're going to obtain 40 kilonewtons. So this is going to be in between now. So you're going to put your 40 kilonewtons like this in between these 4 meters. So which means you're going to divide these 4 meters into 2 equal parts. So that is 4 divided by 2 into 2 equal parts. Okay, so it's going to be 2 meters. So you're going to separate this with 2 meters from the point of B here. Okay, we have another 2 meters because it is supposed to be 4 meters in all this is supposed to be like 4 meters like this, but it's now divided into 2 because of this force that we are now having. So this is now to this point C, so it's now 4 meters to the point C. Okay, so this is going to be the C. So take note, C is a support, so that's why we are having an arrow pointing upwards. Okay, then these forces, they're just normal forces. There is no part that there's nothing that you can actually do here. So this part is going to remain as it is, the one at D and the one at E. We just write these as they are, the 8 kilonewton versus 1 meter. So we have in this case 8 kilonewton with a distance of 1 meter in between. This is directly linked to D. This is for D, this one. Okay, then we have the E, which is 5 kilonewton at the end there, and it's 1 meter. So this one is just right as it is also. All right, that's our 5 kilonewton there, and this is corresponding to E, and we have a distance of 1 meter. Remember that we have a distance of 1 meter in this case here. Okay, so from this part that we are having, from these conditions that we are having, what are we going to do? Because the question now is asking us to calculate the reaction of the supports and motivate your answer. Calculate the reaction of the supports and motivate. So to motivate your answer is actually to use this part that we talked about. If it is in equilibrium, that they are supposed to be equal. Okay, by the first thing, if you are referring to the reactions of the supports that you're talking about are these part here that are pointing upwards, which is B and C. These ones that are actually pointing upwards, these are the supports of what? Of the beam. So these two, B and C. So which means you're supposed to take these moments from the B and also another one from what? From C. So when you're having a diagram like this, it's actually clear now for us to have moments from B. Okay, so you're taking this actually from the point B. Okay, so in the previous class, if you remember, I explained that when you're taking moments about the point B or from the point B, what you're actually doing is that we have your moments. Let me just indicate this, like this is your B. So you're going to close this part with B. So they are actually moments that we can take from these forces which are on the other side of C, which is this C here. So these ones that you are having, they are going to be separated from the ones which are not on the other side of C, which means this one, as we can see, is separate from the side where we are having the support of what? Of C. That's the easier way that I actually take these ones. So you are actually saying from C, we see this side with C, you're going to take all these ones on top. Okay, they are on the same side, and this C and this one, they're on the same side. Okay, so let's write our forces, our moments, I mean. So C back to B is going to be C times 4. There's a distance of 4 there, so it's C times 4 plus, so like I said, this one is on the other side where we are not having C, so it's going to be together with C. So it's 5 versus a distance of 1 meter. So it's 5 times 1, so it's 4 times distance, which is equal, because we no longer have anything on this side, because we are referring to like this side here. We are only having 1, and these forces which are on the side where we are having C, they are all on the other side. So you're going to add these ones together. Okay, so it's 40 back to B. So there's a distance of what? Of 2 meters. So 40 times 2. Okay, so that's how you are simply going to take these ones. So it's 40 times 2 plus 8 back to B. So as you can see here, there is 4 units, 4 meters here plus 1 meter, which is 5 meters from this point here. If you combine with this, 1 meter is going to be 5 meters. So it's 8 by 5. 8 by 5 like this. Plus you move on to the 5 here at the end. So as you can see here, we are going to add 1 meter, because this is 5 plus 1, which is going to give us 6 meters. Okay, so it's 5 by 6 meters like that. So that is the actual these are the moments that we can take about the point B, or from the point B that you're given. Yeah, make sure that the distance that you're going to use here, you use proper distances, and also the directions that you're going to use, make sure that you use proper directions. Okay, so actually we are referring to the sum of the clockwise moments equal to the sum of the anti-clockwise moment. This is actually the part. But are you saying that the way that you're going to take them is actually easier? Yes, you can use that part, but it's easier like this. So I'm going to multiply 4c plus 5 by 1, which is 5, which is equivalent to these ones. You can just multiply them together, then combine. I think that's the easiest way that you can write. You have this. Guys, these things, they are now having they're too much. Okay, let me just write like this. So it's 40 by 2. 40 by 2, and let me just use a bracket so that it can be easier to all of us, plus 8 by 5, which is 40. Anyways, let's just indicate so that all of us will understand. And we have 5 by 6. All right, so you're going to obtain 150 in this case. Okay, so this is 150 that you are obtaining here. Then 4c is going to be equivalent, you subtract 5 from 150, which is going to be something like 145. So you just subtract 5, which is 145. Okay, so you're going to obtain 145. Then you divide by 4. So this answer here, if we divide by 4, we are going to obtain 36.25. Okay, so actually guys, what you're supposed to do, remember this is the force, so it's going to be in kilonewtons. We are supposed to redo this same working that we did, or same calculations that we did, but this time we are taking our moments from the point C, or about C. Okay, so now from the point C, we have the same operation, or the same concept that we had previously. Remember what I said, this is your C here. So if you close this C, we have the point B, the support B. So this B that we are talking about here, yes, the forces which are on the side of B, these ones. These forces that you're going to have, they are the ones that which are equal, or the ones that you're going to add together. Then these forces which are on the other side, where we are not having this B as our support, are the ones that are going together with the point B. These ones on the other side of what? Of B, they're going to go hand in hand with B. Then these ones which are on the same side where we are having B are going to go hand in hand. So these two, they'll be taken hand in hand, just like what we saw when we are working with C like this. We said this is your C. C, as you saw that C was working hand in hand with this one. Why? Because it's on the other side. Then these ones which are on the same side where we are having C were being added together. So it's the same thing with your C now. These ones which are on the other side of B, they'll be together. On the other side of B that we are having this side, they'll be together again. Okay, so let's take these forces. So like I said, we have B back to C, so it's B multiplied by 4 meters. So that is B by 4, plus these ones which are on the other side of B, which is not the side where we are having B, because B is on this side of C. As you can see, this is the side where we are having B. So we're going to take the ones which are on the other side. These are the ones that are actually work hand in hand with B. So that is 8 back to the point C, because we are taking our moments about the point C. Okay, so 8 back to C is going to be 8 times, there's a distance of 1. So that's 8 by 1, plus we have this 5. So between 5 and C, there's a distance of 2 meters. So it's 5 by 2. All right. which is equivalent to, you now take these ones which are on the side where we are having B, on the same side of B, which is 5, back to C. So as you can see 5 here, there's a distance of here there is 4 and 1, so it's 5, so it's 5 by 5. Plus we move on to another one, this is 4, so 4 here back to C, there's a distance of 2 in between here, 4 and what, and 4 and 2. This is 40, sorry, 40 and 2, so it's going to be 40 by 2. Let's hope on the previous part we wrote this as 40. Let me cross check. Okay, yeah, this is 40, so which means that part is fine. So what you simply do is to combine everything. This is going to be 4b plus these two, you can just combine them together, but as you can see this is 8 plus 10, which is 18, but you can just use the calculator, okay, which is equal to this is 25 plus 80, if I'm not mistaken there, this is going to be 80 there, so which is 105, 25 plus 80. Okay, we are going to obtain 105. Okay, then 4b is equivalent to 18 to the other side is going to be 105 minus 18, that's on the other side, which is 87. Then you divide by 4, so this 87, you divide it by 4. Alright, so this is going to be 21,752. So this B is going to be 21,75 kilonewtons. Remember that we are actually referring to the force, which is the reaction of the support, which is at what? At B. So basically, guys, when you are working with these typical questions, what you need to understand is that the moment is actually the force by the distance that you'll be given. So which distance or are you going to refer or are you going to use is important. When you are taking moments about B, you're going to find C. When you take the moments about C, you're going to find B. That is what is important also. Then we are also asked to motivate this answer. So to motivate this answer, what are we going to do? Because this is not the only part that you're given. You're also given to motivate your answer here. So to motivate your answer is actually to prove. So which concept are we going to use in this case? There's from the laws that we talked about, remember we mentioned about this part that the sum of upward forces is equal to the sum of the downward forces. So you can actually use this concept that these are the downward forces that we are having, 5, 40, 8 and 5. These are the forces which are actually going downward. So you can add these ones, 5 plus 14 plus 8 plus 5. So these are the ones which are the downward forces. They must be equal to the upward forces, which means B and what? B and C. So if we add B and C together, we must obtain these two. These two should give us the same. So our B is 21,75 plus C, because these are the upward forces, okay? So this is your C, which is 36,25. So let's add and see if we are obtaining this thing, guys. Already we have 21,75 here, so we're just going to add 36, is 36,25, yeah, 36,25, which is 58, okay? So here I'm obtaining 58 kilonewtons. So let's see there, what you're going to have is 5 plus 40, 5 plus 40 plus 8, 5 plus 40 plus 8 plus 5, okay, like this. Okay, that's 58, so which means we're obtaining the same thing here, 58 kilonewtons, okay? So we're obtaining the same thing, so which means this is actually true or it's fine, yeah, something like that. You can just say it's fine. Okay, so this is our C, which is actually 36,25. So this information you're going to need it, and the other one was 21,75 kilonewtons. Okay, so these are actually positive and positive because they are going upwards, and these ones are negatives. Okay, so this information is the one that you're going to use now when the question is asking you to draw the shear force diagram. Okay, like this part here, draw a shear force diagram using the suitable scale. Show all the main values of the diagram. Okay, so when you're asked to use the suitable scale, you can actually refer to a centimeter representing 5 kilonewton, or you can just represent 1 millimeter representing 1 kilonewton. So what you're actually doing is simply representing these forces, guys. So there's nothing much about this part of the scale that they're talking about. What you simply need is to do this in a proper manner. Okay, so what are you going to have? Remember, there's a distance here, which is of if you are to cross check with a distance, this is 4, 5, 6, 7. That is the distance that you are having. So you can actually do the proper measurements of having 7 centimeters if you need. That is what you are supposed to do. But in this case, let's just assume this is our 7 centimeters, okay? But you're actually supposed to have a proper measurement that you're going to do. But let's just assume this is our 7 meters, which is from the scale that you have chosen, okay? The first force is 5 kilonewton, which is actually facing downwards, this one. So you're going to represent 5 units going downwards, okay? So this is what you're going to do. From this point A, you're going to represent 5 units going downwards. So it's at this point that we are. So this point here, you can just indicate as minus 5 kilonewton, okay? Then if you are to cross check, there is a distance between this A and B of 1 meter, so which means you're going to measure 1 according to the scale that you have used. So you're going to move a distance of 1 like this according to the scale. Then you move upwards 27.5, which means you're going to move upwards, which means you're adding to this minus 5, you're going to add 21.75. so that's something like let's see what you're going to have. Minus 5, that's minus 5 plus 27, 21.75. 21, is it 0.75 or 0.25? It's supposed to be 0.75. Yeah, it's 0.75. It's fine. So we are going to obtain 16.75. So as you can see, if you do the proper measurement, 16.75 is going to be above the line, because this is actually -5. So it's going to be on top of the line. So it's going to be somewhere, let's say this is somewhere here. This is 16.75. Remember what you obtained from your calculator here, 16.75. So you're going to have 16.75 kilonewtons. Okay, then from this 16.75, we are supposed to move to C, because here there is a distributed load which was there. So we are going to move direct to the point C. But moving direct to the point C, how are we going to move? How are we going to do that? We remember we have a force which you are now having of 40. So you're going to move minus 40 to this point, but in a straight line. So this must correspond. So it's 16.75 like this minus 40. You subtract that 40 like this, which is at minus 23.25. Okay, so minus 23.25 is directly actually below this, and it's supposed to be in between 4 meters. So it's supposed to be down at this point. So it's supposed to be, remember, there's a distance of 4 meters. So it's supposed to be 4 meters, but down this point. Let's just say this is the point. Okay, so if this is our point, minus 23.25, minus 23.25 like this, we are then supposed to join from this point like this straight to that point. So that's how you're actually going to do it, because you know that this point, there's a distance that you're already having, which is of 1. So from 1 then to 4, which means this is 5 versus this point, then you join from that. That's how you're going to do it. Okay, So if you are to cross check, this is from the point C going up. You're now going up. There's no distance in between. It's just C going upwards at 36.25. So you're going to add 36.25 and go straight upwards back on the same point, this one, but you're now going upwards with a distance of 36.25. So which means I'm going to add 36.25 because it's going upwards. 36.25. We are now at 18. Okay, so as we can see, 13 is actually below this point 16 from your, according to your measurements, but this is actually below. So let's just say this is our 13. So this is our point 13. So you just do proper measurements, guys. Okay, so from 13 we have 8. There's a distance of 1 meter there, so you're supposed to do proper measurements again, just to move this distance of 1 meter like this. Then you're going to move 8 units downwards. Okay, that's 8 minus 13, which means you're going to end up at what? At 5. You move 8 units downwards, which means you're going to end at 5. Then you're going to have a distance of 1 meter to 5, so that's 1 meter to 0.5. Then you go downwards. Okay, so this is actually 5 here, so it's 1 meter, then you go downwards. So as you can see, according to the proper measurements, this figure is going to close up at the end. So you're supposed to use proper measurements, and this is going to close up like this. That is how you actually represent, and these points are the ones that they are referring to as the main points, these points. So they must be indicated, these main points, when you're answering, because that's where you're actually having marks, because it's not about like having this diagram like that. It's about the clear indication about those points so that you can obtain full marks. Okay, so that's how they can ask these questions. That's how they ask these questions, and we have actually 12 marks for that. So in order for you to actually understand much questions, it's all about the revision, working with more question papers that actually you can understand how they are asking these questions. So that's it, guys, from Memo African Motives. Still working with question papers and revisions on engineering science N3. So not to miss these classes, make sure that you become part of the family, subscribe to my channel, and also don't forget, guys, to share our videos to our friends and colleagues, so that they also can be part of the family and benefit from the family as we move as a family. Memo African Motives.